Solving radical equations is where we are at. So we're a couple days away here from an assessment. This is the last, I believe, if I look right, a couple days on this, a couple days on graphing before an assessment next week. So go ahead. Simplify those. So 4 questions up there, just kind of get you going. Start out. Go ahead and simplify those expressions. So first one, pretty straightforward. Square roots cancel out. So we're just left with 3x minus 1. Second one, cube roots and cubing it, cancel out. So 2x plus 5. This one, you've got to square both of them. So if we square both of them, it gives me 49 times, those cancel out, but that has to stay inside of parentheses. I haven't figured this out yet. 49 times x plus 6, and then distribute. And then the last one. Last one becomes a little bit more difficult because we've got the addition sitting in here. So with this last one, the best way to do this last one is x minus 5 plus 3 times the square root of x minus 5 plus 3. What it means to square it. And again, you could do this for all of them. It's going to work out the same way. I mean, if you did this same thing and wrote it twice and just did your distributed stuff, it works out the same exact way. So now when you FOIL this, first that becomes the square root of x minus 5 squared, because we did it twice. Inside is 3 and 3, so it's going to be, so if we do this twice, so that's plus 3 times the square root of x minus 5 and 3, so that's plus 6 times the square root of x minus 5. And then 3 plus 3 is 9, so you got the 9 at the end. Those cancel, leaving you with x minus 5 plus 6 times the square root of x minus 5 plus 9. Combine like terms. Square root of x minus 5 plus 4. And that's just how that one has to end up. You can't take it any further than that. But it's simply simplifying expressions and keeping in mind when you take the square root of something and you square it, or you take the cubed root of something and you cube it, you're just left with what's underneath. And you guys have done that a lot. Okay, we did that several times. Okay, again, I just didn't distribute that one. If I would have distributed that one, that's where we would have been and doing. So what are we going to do today? We're going to solve rational equations with one variable and give examples showing how extraneous solutions may arise. We won't do that part of it. The standards, whatever. Lesson goals. Okay, so radical equations. So we're going to solve radical equations. When you're solving radical equations, we're going to do it in 3 steps. The first step for solving radical equations is to isolate the radical on one side of the equation. So that's step 1. So remember what your radical equations look like. We're talking about something like the square root of x plus 5 plus 2 equals 8. Something like that. That's an example of a radical equation. Step 1 in solving radical equations is to isolate the radical. Okay, so in the case we have up there, we're just going to go ahead and subtract 2 from both sides. So now we're ending up with the square root of x plus 5 equals 6. So we've isolated it. The next thing we need to do is eliminate the radical. Raise each side of the equation to a power equal to the index of the radical. So the index of our radical in this case isn't shown, so it's just 2. So you get rid of the square root by squaring something. That's what that says, just like in the warm-ups. Squaring it eliminated square root. Cubing it eliminated cube root. Squaring this is going to eliminate the square root. So we're going to square both sides. The squaring eliminates the square root, so we're just left with x plus 5 equals 36. Solve the resulting polynomial equation and check the result. So you subtract 5 from both sides, you get x is equal to 31. Now, it's important with this stuff that you check the result to make sure that it works, because you are going to get extraneous solutions. Just like we did, you can't divide by 0. We're going to get solutions in here that don't work. It might make this negative. And if we make a negative in here, it's not going to work because our result is positive. We can't take that negative square root without having our imaginary numbers. We're not going into that realm. So 31 plus 5 is 36. Square root of 36 is 6. 6 plus 2 is 8. It checks out. It works. You always have to check your results when you're doing these. Make sure it works. Plug it in. And it's the only way you can check it. If you plug it in and it doesn't work, the answer is not that. Something else. Okay, so 3 steps. Isolate. Eliminate the radical by raising each side of the equation to a power equal to the index of the radical. And then solve and check your solution. Okay, so let's take a look at this one. We got the square root of 3x minus 5 plus 2 is equal to 6. Step 1, isolate the radical. So that means we need to subtract 2 from both sides of the equation. Subtracting 2 from both sides of the equation leaves me with 3x minus 5 is equal to 4. So we've got step 1 done. Step 2 is to raise it to the power of the index. Just square it again. So we're going to go ahead and square both sides. Squaring something eliminates the square root. We're left with 3x minus 5 is equal to 16. Solve. Add 5. 3x equals 21. X is equal to 7. We need to check our solution. 3 times 7 is 21. 21 minus 5 is 16. Square root of 16 is 4. 4 plus 2 equals 6. It checks out and it works. And just quick, plug it in. Make sure it works when you're solving them. Okay. Equal equation, subtract, square, simplify, check your results. Okay, so let's look at this one. So now I've got 4 times 2x plus 6 to the 1/3 minus 9 equals 3. What are we going to do first? Add 9. We still have to isolate. We're going to add 9. So we have 2x plus 6 to the 1/3. Oops, 4 times 2 equals 12. Divide by 4. So 2x plus 6 to the 1/3 equals 3. So we've got it isolated. Now we have to raise it to the index. What's the index of 1/3? 3. The index is 3. Remember how I could rewrite this? this would be rewritten as the cubed root of 2x plus 6. So our index is the 3. So I could, instead of rewriting it like this works perfectly fine. I could rewrite this just as multiplying it or taking it to the third power. It's the same thing. Because if you think about it this way, power to power, you multiply, right? So if I take 1/3 to the third, 1/3 times 3 is 1. So in a sense, I've canceled that out, which is the same thing as if I do this. They're both the same operations, whether I raise it to the power of my index or I make this 1. Talk about it more in that comment more in a second. But either way, we've eliminated it, and we're sitting with 2x plus 6 is equal to 27. 2x equals 21. X equals some gosh awful number. 10.5. Okay, so we have a possible answer of 10.5. We have to check it. So we've got 10.5 times 2. Well, that's just 21, right? Got 21 plus 6. 27. The cubed root of 27 is 3. 3 times 4 is 12 minus 9 is? It works. Okay, yes, it was an ugly fraction. This is a case, and a lot of these are going to be the case where, generally speaking, I hate fractions. But a lot of times these are, if you put them as decimals, easier to check. Okay, especially if you're not very good with fractions. Actually, if you're good with fractions, it's not that bad either, but whatever. Questions with that one? So there it is. I think that's what we did. We checked it. We found out that it was true. They used 21 halves.
Is this the only thing that we have to do today?
Of course. It gets more fun. So we're going to solve this and identify the extraneous solutions, but we're going to solve it too. What are our thoughts on solving this?
That we just square both of them? Just square it. Okay.
I like that idea. Do that.
Oh, good job. Really?
Square both sides right away. Can you really isolate a radical?
No.
No, you can't really isolate the radical. You've got this x plus 21, the square root of that on one side, and you've got this on the other. Could you put this radical on this side? Sure, you could. But it might create some issues. So let's square both sides. See what happens if we square both sides. So let's do that first. So we're going to square, and we're going to square. What's the left-hand side? Just x plus 21. Right-hand side's not quite that easy. And this is why we did that one. This is why we did the warm-up. Remember, squaring something means taking it times itself. And because we have this subtraction in here, we just can't individually square these. These have to stay as a thing. Okay? Again, I know part of you just wants to square each of those and get 9 minus x. It doesn't work that way. These have an operation between them. And because they have a subtraction operation between them, we need to treat them like this, which you're going to see is going to create a problem in just a second. So we got x plus 21 is equal to 9. 3 times 3 is 9. We've got minus 3 radical x minus 3 radical x. So that's minus 6 radical x. Does that make sense? plus what? Radical x times radical x, which is radical x squared, which is just x. So this is going to be plus x. Radical x times radical x gives us radical x squared. Just cancels. Okay. Now what do you think I should do? We have another radical. We still have a radical, but now we only have one radical. So what should we do? Get it alone. And so now we're going to isolate the radical, which is right there. So we're going to subtract x, and you're going to say, oh, thank you for doing this. So we subtract x, subtract 9. I'm going to skip everybody see what I'm doing? We're trying to get a radical all alone. So x minus x is nothing. 21 minus 9 is 12. So 12 is equal to negative 6 times radical x. In agreement so far? That look right? So negative 2 is equal to? Radical x. Radical x. Square it. X equals 4. See if it works. Does everybody see how we got 4? This was negative 2. It's just my handwriting is horrible. It's my handwriting is horrible. Yeah, I don't know. I think in my head I did say 1. But I wrote negative 2. Yeah. So 4 plus 21. 25. Square root of 25 is 5. 3 minus the square root of 4 is 2. 3 minus 2 is that? Do these equal the same? Is that a solution? No, it's not a solution. Okay, so it's an extraneous solution. Okay, it appears that it works. Mathematically, it looks like it works. But when you go back and check it, it does not work. So you always have to check these, looking for these extraneous solutions. Okay. And it's a false statement because we stated why. Now let's look at this one. So now we have 2/3 times x plus 14 to the 1/6 power plus 8 equals 10. So I only got one x in there. That's probably a good thing. Doesn't look like that last one where we got multiple things going on. So because we only have one kind of x sitting in there and one essentially radical sitting in there, isolate it. So we're going to subtract. What am I doing? 8. Subtracting 8. So subtract 8. So that gives me 2/3 times 11x plus 14 to the 1/6 is equal to 2. Now what? Divide 2/3, which is the same thing as multiplying by 3/2. So we're going to multiply each side by 3/2. Shh, ladies. We just multiply by the reciprocal. Then this is gone. So we're left with 11x plus 14 to the 1/6 power is equal to 3. Now, what power can I take this to? The 6th. Okay, I'm going to raise this to the 6th power. It's the reciprocal of this. If this is 2/3, take it to the 3/2 power. If this is 3/4, take it to the 4/3 power. Whatever this is, you just need to raise it to its reciprocal's power. Because when you multiply by its reciprocal, you just get 1. So we're taking that to the 6th, we're taking that to the 6th. So I've got 11x plus 14 is equal to 729. Now you guys can solve equations. Subtract 14. 11x equals 715. Divide by 11. You get a nice number? Nice. You get x is equal to 65. And then you check it. Okay? Plug it in there, check it the best you can. We'll see if it works. We'll just let the board do it for us. It gets 65 like we were supposed to. Eesh. It's different. I think it probably just says it works. Okay? Are we good? We're not going to do the by graphing part. Are we okay solving these?
Yes.
So far, so good? There's so much more that we could do with this. We're not going to do it. We don't do these with graphing calculators. Maybe in a couple years we will. But this year, we are not doing it with calculators. I want you to do question number 3. Question number 3 is the one I want you to work on. I'm going to do one more as kind of your exit ticket, but I want you to do question number 3. Now, hint with number 3, move the x to the other side of the equation. It makes it easier. Because there are 2 of these, move the x to the other side. Don't isolate it if there's more than one square root. Number 3, and we'll call it a day.